On the morning of September 23, 1944, at 0630 hours, Lieutenant Colonel Russell Ayres crouched in a coral depression on Peleliu's Bloody Nose Ridge, watching his Marines die trying to advance against an enemy they couldn't even scratch. At 42 years old, he was one of the oldest combat officers in the 1st Marine Division, a veteran of the Banana Wars in Nicaragua who thought he'd seen every form of fortification the enemy could devise. But nothing had prepared him for this. The Japanese had transformed Peleliu's limestone hills into a fortress that swallowed American lives without yielding an inch of ground. In the first 5 days of the assault, his battalion had suffered 217 casualties trying to reduce bunker positions that absorbed direct hits from naval gunfire, tank cannons, and aerial bombardment without effect. The reinforced concrete structures built into the coral ridges seemed indestructible, each one a miniature fortress with interlocking fields of fire that turned every Marine advance into a slaughter. Through his field glasses, Ayres watched another platoon attempt to assault Hill 80, their flamethrowers and satchel charges useless against firing ports protected by 3 feet of reinforced concrete and 20 feet of solid limestone. The Japanese machine guns opened up from positions the Marines couldn't see, cutting down riflemen who never even located their killers. Major Teramichi Yamaguchi's engineers had spent 14 months building these positions, using construction techniques borrowed from European fortress design and adapted for the Pacific's brutal combat conditions. Every bunker was positioned to support adjacent positions, creating defensive zones where American firepower simply disappeared into the coral without effect. But that morning, Ayres received word that something new had arrived on the beaches below. The United States Army's 514th Field Artillery Battalion had landed their M1918 8-inch howitzers during the night, massive weapons designed for destroying hardened fortifications that even battleship guns couldn't penetrate. Each shell weighed 200 pounds and carried enough high explosive to collapse structures built to withstand anything the Japanese engineers had imagined possible. The problem wasn't Japanese bunkers alone, though those were deadly enough. It was the complete tactical system Yamaguchi had created, turning Peleliu's natural limestone ridges into a killing ground, where every American advantage in mobility and firepower became irrelevant. The Marines had trained to assault beach defenses and overcome machine gun nests with aggressive infantry tactics. But Yamaguchi's bunkers weren't on beaches. They were buried inside mountains, with firing ports so carefully concealed that Marines couldn't identify targets until Japanese guns opened fire at point-blank range. Lieutenant William Hawkins had led his platoon against the same bunker complex 3 times in 2 days, losing 14 men without ever getting close enough to use demolitions effectively. The Japanese positions absorbed everything the Marines could throw at them. 75mm tank rounds bounced off reinforced concrete. Napalm burned harmlessly around sealed firing ports. Even direct hits from naval 5-inch guns only chipped the surface of bunkers protected by layered construction that dissipated explosive force through carefully calculated spacing between concrete walls and natural coral formations. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The morning sun cast harsh shadows across Peleliu's tortured landscape, as Lieutenant Colonel Ayres surveyed the killing field his Marines had inherited. The 1st Marine Division had landed on September 15th expecting to secure the island in 3 days. Now, 8 days later, the offensive had ground to a complete halt against fortifications that defied every tactical manual the Corps possessed. The problem wasn't simply that the bunkers were strong. It was that Major Yamaguchi had created a defensive system that turned American firepower into a liability. Every time Marines called in naval gunfire or airstrikes, the Japanese simply withdrew into their deep bunkers and waited. When the bombardment lifted, they emerged to man firing positions that remained completely intact, cutting down Marines who assumed the enemy had been destroyed. Colonel Kunio Nakagawa, commanding Peleliu's garrison, had studied American tactics during the campaigns at Tarawa and Saipan. He understood that the Marines relied on overwhelming firepower to suppress enemy positions before infantry assault. The traditional Japanese response, beach defenses and banzai charges, had failed catastrophically when faced with American naval gunfire and close air support. Nakagawa's solution was to abandon the beaches entirely and create a defense in depth built around positions that American weapons simply couldn't destroy. The limestone ridges of central Peleliu provided perfect terrain for this strategy. The coral rock was soft enough to excavate with hand tools, but hard enough to provide natural protection against artillery fire. Japanese engineers had spent over a year creating a network of bunkers, caves, and connecting tunnels that turned the entire ridge system into a single fortified position. Each bunker was built according to specifications developed by Imperial Army engineers who had studied European fortification design from the First World War. The standard Type A bunker measured 12 feet wide, 8 feet deep, and 7 feet high, with walls constructed from reinforced concrete poured over steel frames salvaged from destroyed ships and construction equipment. The concrete itself was mixed, using coral sand, cement imported from Japan, and seawater, creating a substance that cured to incredible hardness in Peleliu's tropical climate. Each bunker required 4 weeks to construct, using labor from Korean forced workers and Japanese combat engineers. The walls were 3 feet thick at minimum, with additional protection provided by positioning bunkers inside natural coral depressions or caves that added another 10 to 20 feet of overhead cover. Firing ports measured only 6 inches high and 12 inches wide, just large enough for a Type 92 heavy machine gun barrel to extend through, while providing almost no target for American return fire. The machine guns themselves were mounted on sliding rails that allowed Japanese gunners to fire, then withdraw their weapons completely inside the bunker before Marines could identify the firing position. This technique made counter-battery fire virtually impossible, as American gunners had nothing to aim at except solid coral and concrete. Lieutenant Hawkins had attempted to map the bunker positions by observing muzzle flashes during Japanese fire, but the positions were so well concealed that even experienced Marine scouts couldn't determine their exact locations. Yamaguchi's defensive plan called for interlocking fields of fire that ensured no American soldier could approach any single bunker without exposing himself to crossfire from adjacent positions. The bunkers were positioned in depth, with front-line positions covering obvious approach routes while secondary bunkers covered the flanks and rear areas of the forward defenses. Marines who managed to assault and destroy one bunker immediately came under fire from positions they hadn't even known existed. The psychological impact on Marine infantry was devastating. Ayers watched his men advance with increasing reluctance, knowing that every step forward brought them closer to invisible machine guns that could open fire without warning. The aggressive tactics that had served the Marines well at Guadalcanal and Tarawa were useless against an enemy who couldn't be seen until he started killing. Traditional Marine doctrine emphasized fire and maneuver, with rifle squads providing covering fire while assault teams closed with the enemy. But covering fire required visible targets, and Yamaguchi's bunkers provided none. Marines fired thousands of rounds at coral ridges without effect, while Japanese machine gunners waited patiently for Americans to expose themselves during their advance. The few bunkers that Marines had managed to destroy required extraordinary effort and casualties. Sergeant John Basiloni's squad had reduced one position on September 18th by approaching through a ravine that provided cover from Japanese observation, then using pole charges to blow open the firing port and throw satchel charges inside. The effort had taken 6 hours and cost 4 Marine lives to eliminate a single bunker that held a 5-man Japanese crew. At that rate, clearing Peleliu's estimated 300 bunker positions would require months and thousands of casualties. Naval gunfire had proved equally ineffective against the hardened targets. The battleship USS Pennsylvania had fired over 814-inch shells at the ridge positions on September 16th, creating spectacular explosions that destroyed vegetation and churned up coral dust, but left the concrete bunkers completely intact. The shells, designed to penetrate ship armor or destroy surface structures, simply lacked the penetrating power to reach bunkers protected by layered defenses. Even direct hits on bunker roofs failed to penetrate the combination of reinforced concrete and coral overburden that Yamaguchi's engineers had calculated to withstand anything in the American arsenal. Airstrikes using 500-pound bombs produced similar results. Navy and Marine Corps aviators made repeated attacks on identified bunker positions, placing their bombs with impressive accuracy. But the explosions, devastating as they appeared, occurred on the surface while the Japanese positions remained buried safely beneath layers of protective material. The blast waves and fragmentation that made aerial bombs so effective against surface targets dissipated harmlessly when confronting hardened underground fortifications. Major Robert Rogers, commanding the battalion's weapons company, had experimented with every available option for destroying the bunkers. His 75mm pack howitzers could deliver shells with reasonable accuracy, but lacked the shell weight and penetrating power to damage reinforced concrete. The regimental cannon company's 75mm guns faced the same limitations. Even the M4 Sherman tanks supporting the Marine advance found their 75mm cannons inadequate for bunker reduction. The shells would strike concrete, create impressive impacts, and leave the structure essentially undamaged. The problem, Rogers realized, wasn't American firepower in general. It was the specific characteristics of the weapons available to the Marines. They possessed tremendous firepower measured in total explosive weight delivered, but lacked the heavy shells with proper fusing and trajectory needed to penetrate hardened fortifications. What the Marines needed was siege artillery, weapons designed specifically for destroying reinforced structures through a combination of shell weight, explosive force, and penetrating impact. Captain James Mitchell had served as forward observer with the Army's heavy artillery during the Italian campaign, where he had witnessed 8-inch howitzers reducing German fortifications in the Gothic line. He approached Ayres that morning with a suggestion born from his European experience. The Army had landed heavy artillery on Peleliu's beaches, weapons far more powerful than anything in the Marine Corps inventory. The M1918 8-inch howitzer could fire 200-pound shells to ranges exceeding 16,000 yards, with enough penetrating power to destroy any fortification the Japanese could construct. The shells were designed specifically for attacking hardened targets, with heavy steel cases and delayed action fuses that allowed penetration before detonation. Mitchell had watched these weapons demolish German bunkers built to First World War specifications, and he believed they represented the only solution to Peleliu's defensive system. Ayres contacted Army Artillery Command that afternoon, requesting fire support from the newly landed howitzer battalion. The request represented a significant departure from standard operating procedure. Marine Corps doctrine emphasized organic firepower under Marine Command, and the idea of relying on Army artillery for close support operations violated institutional preferences that had developed over decades of inter-service rivalry. But Ayres understood that his Marines were dying because they lacked weapons capable of reaching the enemy, and institutional pride seemed less important than finding solutions that worked. The Army's 514th Field Artillery Battalion had arrived on Peleliu's beaches during the night of September 22nd. Their massive howitzers transported aboard LSTs specially configured for heavy cargo. Each M1918 weighed nearly 15,000 pounds and required a prime mover to position, making them among the heaviest weapons deployed in the Pacific Theater. Lieutenant Colonel Harold Mason commanded the battalion with 8 howitzers organized into 2 batteries of 4 guns each. His crews had trained extensively in bunker reduction techniques during their preparation for the European theater, but had been diverted to the Pacific when intelligence reports indicated the Japanese were building fortified positions similar to German Atlantic Wall defenses. The 8-inch howitzer represented the pinnacle of American heavy artillery design, a weapon that combined enormous destructive power with sufficient mobility for amphibious operations. Developed during the First World War and refined throughout the interwar period, the M1918 could fire shells weighing 200 pounds to ranges that exceeded most counter-battery threats. The shells themselves were engineering marvels, precision manufactured to tolerances measured in thousandths of an inch to ensure consistent ballistics and maximum penetrating performance. Each shell measured 8 inches in diameter and 29 inches in length, with a steel case 3/4 of an inch thick at the nose. The explosive charge consisted of 40 pounds of TNT, more than enough to destroy any structure if detonated inside the target. But the shell's real innovation lay in its fusing system, which could be adjusted for different types of targets. For bunker work, gunners selected delayed action fuses that allowed the shell to penetrate concrete or earth before detonating, maximizing damage to buried structures. The ballistic trajectory of the 8-inch howitzer gave it additional advantages over direct fire weapons when engaging hardened targets. Unlike tank cannons or anti-tank guns that fired on flat trajectories, the howitzer lobbed shells in high arcs that brought them down almost vertically on target. This plunging fire struck bunker roofs, typically the weakest point in any fortification since engineers concentrated protective thickness on front and side walls expected to face direct fire. A 200-pound shell arriving at terminal velocity from high altitude possessed enormous kinetic energy in addition to its explosive power, allowing penetration through multiple feet of reinforced concrete before the fuse triggered detonation. Mason's gun crews had practiced their firing procedures until they achieved rates of fire approaching 1 round per minute, remarkable for weapons that required manual loading of shells weighing as much as a full-grown man. Each gun crew consisted of 11 men, with specific responsibilities for ammunition handling, fuse setting, loading, aiming, and fire control. The process began with fire direction calculations performed by battery officers using surveying instruments and trigonometric tables to convert target coordinates into gun elevation and azimuth settings. Forward observers like Captain Mitchell would identify targets and radio coordinates to the fire direction center, where officers calculated the precise gun settings needed to place shells on target. The calculations accounted for range, elevation differences between gun position and target, wind speed and direction, air temperature, and even the rotation of the earth for long-range shots. Once firing data reached the gun crews, the process of preparing and firing a round required approximately 50 seconds. Ammunition handlers retrieved shells from protected storage positions and transported them to the gun. The fuse setter adjusted the delayed action mechanism according to the type of target and estimated overhead protection. Loaders manhandled the 200-pound shell into the breech, followed by the separate propellant charge that provided the explosive force to launch the projectile. The gun commander verified elevation and traverse settings, then gave the order to fire. The actual firing sequence produced a thunderous blast that could be heard for miles, as the propellant charge detonated and drove the heavy shell up the 8-inch barrel at velocities approaching 1,500 feet per second. The recoil mechanism absorbed over 100,000 pounds of force, allowing the gun carriage to remain stable, while the barrel traveled backward nearly 4 feet before returning to battery. Spotters observed the shell's impact and radioed corrections if needed, allowing subsequent rounds to walk onto target with increasing accuracy. The first test of the 8-inch howitzers against Peleliu's bunkers came on the afternoon of September 23rd, when Captain Mitchell identified a particularly troublesome Japanese position on Hill 80 that had held up Marine advances for 3 days. The bunker was positioned inside a natural coral cave with approximately 20 feet of overhead cover and concrete walls protecting the firing port. Marines had attempted every available method of destruction without success, losing 11 men in the efforts. Mitchell radioed the target coordinates to Mason's Fire Direction Center, describing the bunker's construction and requesting delayed fuse shells for maximum penetration. The first 8-inch shell left the howitzer at 14:20 hours, arcing through the clear afternoon sky in a trajectory that peaked at over 2,000 feet before descending toward Hill 80. Marines watching from forward positions heard the distinctive whistle of the falling shell, a sound unlike anything produced by the smaller caliber weapons they were accustomed to. The shell struck the coral hillside approximately 15 feet from the bunker entrance, penetrating 8 feet into the limestone, before the delayed fuse triggered detonation. The explosion was extraordinary, nothing like the sharp crack of smaller shells. Instead, a deep rumbling boom seemed to emanate from inside the earth itself as 40 pounds of TNT detonated underground. The entire hillside shuddered and a geyser of pulverized coral erupted skyward, followed by a cloud of gray dust that obscured the target area completely. When the dust cleared, Marines could see that the explosion had created a crater 12 feet deep and 20 feet across, completely altering the terrain features around the Japanese bunker. But more importantly, the shock wave from the underground detonation had traveled through the coral formation and struck the bunker's concrete walls with devastating force. Cracks appeared in the reinforced structure, and the carefully positioned firing port had shifted out of alignment. Mason's crews fired a second shell 3 minutes later, placing it directly on top of the damaged bunker. This round penetrated through 15 feet of fractured coral and 3 feet of cracked concrete, before detonating inside the bunker itself. The explosion was catastrophic, with blast pressure and fragmentation killing the 5-man Japanese crew instantly, while the structure collapsed inward on itself. The firing port disappeared entirely, buried under tons of rubble and shattered concrete. The bunker that had held up a Marine battalion for 3 days had been eliminated in less than 10 minutes by 2 shells from a weapon the Japanese defenders had never encountered. Lieutenant Colonel Ayres observed the results through his binoculars, watching in disbelief as the supposedly impregnable bunker simply ceased to exist. The psychological impact on his Marines was immediate and profound. Men who had been pinned down by Japanese fire for days suddenly understood that effective solutions existed for positions they had considered indestructible. Word spread rapidly through the battalion that new weapons had arrived, artillery powerful enough to destroy any bunker the Japanese possessed. Major Yamaguchi witnessed the destruction from his command post deeper inside the ridge complex and immediately understood the implications. The Americans had deployed weapons specifically designed to counter his fortifications. Siege artillery that could penetrate the protective layers he had calculated would stop any shell in the American inventory. The carefully constructed defensive system he had spent 14 months building was suddenly vulnerable to a weapon he had not anticipated. The successful engagement prompted immediate tactical adjustments throughout the Marine Division. Forward observers began identifying high-priority bunker targets for 8-inch howitzer fire, while infantry units prepared to exploit the opportunities created when Japanese positions were destroyed. The weapons that had seemed adequate for Pacific warfare, tank cannons and medium artillery, were being supplemented by siege guns that changed the fundamental equation of bunker warfare. Mason's battalion fired 68 rounds that afternoon, systematically destroying bunker positions that had held up the Marine advance since the landing. Each target required careful fire direction calculations and multiple rounds to ensure complete destruction, but the results justified the ammunition expenditure. Japanese positions that had absorbed hundreds of smaller shells without effect collapsed under the penetrating impact of 200-pound projectiles that reached them through layers of protective coral and concrete. The thunder of 8-inch howitzers firing became a constant background sound across Peleliu's battlefield, as Army gun crews settled into a rhythm of sustained fire support. The massive shells arced overhead in trajectories that brought them down almost vertically on Japanese positions, each impact creating shock waves that traveled through the limestone formations and shattered bunkers from within. Marines advancing behind the artillery barrage encountered destroyed positions and stunned Japanese survivors who had believed their fortifications were proof against any American weapon. The success of the 8-inch howitzers demonstrated that technological innovation could overcome even the most sophisticated enemy defenses when applied with proper coordination and tactical understanding. The Japanese had created defensive positions based on calculations about American firepower that were accurate but incomplete. They had protected against naval gunfire and medium artillery without considering the possibility of siege weapons specifically designed for bunker reduction. The M1918 8-inch howitzer represented the culmination of American artillery development that stretched back to the siege warfare of the First World War, where static trench systems and reinforced bunkers had dominated the Western Front. Engineers at the Watertown Arsenal in Massachusetts had designed the weapon specifically to destroy hardened fortifications that resisted lighter artillery, creating a gun that balanced destructive power with sufficient mobility for offensive operations. The barrel alone measured 12 feet in length and weighed over 6,000 pounds. Manufactured from high-grade steel forged to withstand chamber pressures exceeding 35,000 pounds per square inch. The rifling inside the barrel consisted of 48 grooves cut in a uniform right-hand twist that spun the shell at approximately 150 revolutions per second, stabilizing its flight and ensuring accuracy at maximum range. This precision manufacturing allowed gun crews to place shells within 50 yards of their aim point at ranges exceeding 10 miles, remarkable accuracy for weapons firing in high arc trajectories where small variations in propellant temperature or wind speed could cause significant deviation. The 200-pound high-explosive shell was itself an engineering achievement that reflected decades of metallurgical research and explosive chemistry refinement. The shell body was forged from a single billet of high-carbon steel heated to 2,200 degrees Fahrenheit and shaped using hydraulic presses that exerted over 15,000 tons of force. This manufacturing process created a shell casing with walls 3/4 of an inch thick at the nose, tapering to 1/2 an inch at the base, providing maximum strength where penetration forces would be greatest while minimizing overall weight. The interior cavity held 40 pounds of cast TNT, poured molten into the shell body, and allowed to cool slowly to prevent cracking or void formation that could cause premature detonation. The explosive filler represented 20% of the shell's total weight, a ratio carefully calculated to maximize blast effect while maintaining sufficient structural strength for penetration. The fusing system distinguished bunker-busting shells from standard high-explosive rounds used against surface targets. The M51 delayed action fuse screwed into the nose of the shell and contained a precisely machined firing pin held in place by a spring-loaded safety mechanism. Upon impact, the safety released and allowed a weighted hammer to strike a percussion cap, but the actual detonation was delayed by a powder train that burned for a precisely measured interval. Engineers could adjust this delay from 0.1 seconds to 0.5 seconds, allowing the shell to penetrate different depths before exploding. For Peleliu's bunkers, gunners typically selected 0.3-second delays, enough time for the shell to punch through 15 to 20 feet of coral and several feet of reinforced concrete before the TNT detonated inside or immediately behind the protective barriers. Sergeant Thomas Anderson commanded Gun Number 3 in Battery A, and he understood the weapon's capabilities better than most after 18 months of training at Fort Sill's Artillery School. He had calculated that a 200-pound shell striking at terminal velocity of approximately 800 feet per second carried kinetic energy equivalent to a fully loaded truck hitting a brick wall at 60 miles per hour. This impact force, combined with the shell's hardened steel nose and aerodynamic shape, allowed penetration through materials that would stop lighter projectiles completely. The subsequent detonation of 40 pounds of TNT inside a confined space like a bunker created blast pressures exceeding 5,000 pounds per square inch, enough to pulverize concrete and collapse any structure not specifically designed to withstand internal explosions. Major Yamaguchi's bunker designs had incorporated protection against every American weapon his intelligence staff had identified during their analysis of previous Pacific campaigns. He had studied the effects of naval gunfire at Tarawa, where Japanese beach defenses collapsed under bombardment from battleship main batteries. His engineers had reviewed damage assessments from Saipan, where American artillery had reduced Japanese fortifications through sustained fire. The Type A bunker specifications reflected lessons learned from these analyses, with reinforced concrete walls calculated to withstand direct hits from 5-inch naval shells and overhead protection sufficient to stop aerial bombs up to 1,000 pounds. What Yamaguchi had not anticipated was the deployment of 8-inch siege howitzers, weapons that had been reserved primarily for the European theater, where German fortifications required the heaviest American artillery. The concrete mixture used in Peleliu's bunkers consisted of 1 part Portland cement to 3 parts coral sand aggregate, mixed with seawater in ratios that produced a substance with compressive strength approaching 4,000 pounds per square inch when fully cured. Japanese engineers had tested various formulations during the 14 months of construction, seeking the optimal balance between strength and workability that allowed pouring in Peleliu's tropical climate. The final mixture incorporated steel reinforcement bars salvaged from destroyed merchant ships, creating a composite structure that distributed stress and prevented catastrophic failure from single impacts. Each bunker required approximately 8 cubic yards of concrete, mixed by hand and carried in buckets to the construction site where Korean laborers poured it into wooden forms built around the steel framework. The standard bunker configuration placed 3 feet of reinforced concrete on all sides, with additional protection from natural coral formations that surrounded most positions. Firing ports were designed as narrow slots that restricted incoming fire while allowing Japanese machine gunners to sweep wide arcs with their Type 92 weapons. The ports were angled slightly downward to cover approaches at ground level while making it nearly impossible for American forces to fire directly into the opening. Interior spaces measured just large enough for a 5-man crew and ammunition storage, with ventilation provided through concealed ducts that prevented toxic gas accumulation from American chemical weapons. The entire structure was designed to function as a self-contained fighting position that could hold out indefinitely as long as the crew remained alive and ammunition lasted. Lieutenant Hiroshi Tanaka commanded the bunker complex on Hill 100, the highest point in Peleliu's ridge system, and the key to the entire Japanese defensive position. His fortifications included 6 interconnected bunkers linked by tunnels that allowed movement between positions without surface exposure. Each bunker covered specific approach routes with overlapping fields of fire that ensured no American soldier could reach any position without exposing himself to multiple machine guns simultaneously. Tanaka had personally supervised the construction of these defenses, watching as engineers blasted chambers into the coral and built concrete walls that he believed could withstand anything the Americans possessed. His confidence was based on practical experience. During the first week of battle, his positions had absorbed direct hits from naval 5-inch guns, 75mm tank cannons, and 500-pound aerial bombs, without suffering significant damage. Marines who attempted to assault his bunkers died in their dozens, unable to reach positions protected by interlocking fire and reinforced construction. The morning of September 24th brought clear skies and calm winds, ideal conditions for precision artillery fire. Captain Mitchell had identified Hill 100 as the primary obstacle to continued Marine advance, and he requested concentrated fire from all 8 howitzers in Mason's battalion. The fire mission would represent the largest coordinated bombardment yet attempted against a single objective, with each gun assigned specific targets within the defensive complex. Mason's Fire Direction Center calculated trajectories and propellant charges, accounting for the elevation difference between the gun positions on the coastal plain and the targets nearly 200 feet higher on the ridge. The mathematics required precise surveying and trigonometric calculations that filled multiple pages of logarithm tables and firing charts. Each gun would fire at slightly different elevations and azimuths to distribute shells across the target area, ensuring comprehensive coverage of all bunker positions. The bombardment began at 0900 hours, with all 8 howitzers firing simultaneously. The sound was extraordinary, a rolling thunder that echoed across the island and out to sea where Navy ships recorded the blast on their instruments. 8 200-pound shells arced into the sky, reaching apexes over 3,000 feet before beginning their plunge toward Hill 100. Marines in forward positions watched the shells descend, black dots against the morning sky that grew larger as they fell toward the Japanese positions. The first impacts occurred within a 2-second window, 8 massive explosions that seemed to lift the entire hillside. Coral dust and pulverized rock erupted skyward in geysers that merged into a single cloud, obscuring the entire target area. The ground shook violently enough that Marines a quarter-mile away felt the tremors through their boots, while the blast waves rolled across the battlefield like physical pressure. Lieutenant Tanaka was in bunker number 3 when the bombardment began, conferring with his machine gun crew about ammunition conservation. The first shell struck 50 feet from his position, penetrating deep into the coral before detonating with a force that collapsed one wall of the connecting tunnel. The explosion was unlike anything he had experienced during a week of constant American fire. Instead of surface detonations that created noise and debris without threatening the bunker's integrity, this blast seemed to come from beneath the ground itself, transmitting shock waves through the limestone that cracked concrete and shifted steel reinforcement. Before he could assess the damage, a second shell struck directly above bunker number 1, penetrating through 25 feet of coral and 3 feet of concrete roof before detonating inside the structure. The 5-man crew died instantly as blast pressure and fragmentation filled the confined space. The reinforced walls that had protected them from external fire became death traps when the explosion occurred within, reflecting blast waves that multiplied the destructive effect. Mason's gun crews reloaded and fired again, establishing a rhythm that delivered shells at approximately 1-minute intervals. The sustained bombardment walked across Hill 100 systematically, with forward observers adjusting fire to ensure complete coverage of all identified positions. Shells that missed bunkers by 50 or 100 feet still contributed to the destruction, as their underground detonations fractured the coral formations and destabilized the geological structure supporting the defensive positions. Tanaka ordered evacuation of the remaining bunkers as the American fire intensified, recognizing that his carefully constructed fortress was being systematically demolished by weapons against which he had no defense. His men fled through connecting tunnels toward deeper cave positions in the ridge's interior, abandoning machine guns and ammunition they could not carry. The bunkers that had cost 14 months of labor and represented the finest defensive engineering the Japanese army could produce were being reduced to rubble in less than an hour. By 0945, Mason's battalion had fired 96 shells at Hill 100, expending nearly 10 tons of high explosive against the defensive complex. The hillside had been transformed from a fortified position into a moonscape of overlapping craters and collapsed structures. Of the 6 bunkers Tanaka had commanded, 5 were completely destroyed, with their concrete walls shattered and firing ports buried under tons of debris. The sixth bunker remained structurally intact, but was isolated from the defensive network. Its connecting tunnels collapsed, and its field of fire blocked by rubble from adjacent positions. Marines advancing behind the artillery barrage encountered no resistance from positions that had held them at bay for over a week. Japanese survivors who had retreated into the caves were too shocked and disorganized to mount effective defensive fire. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The psychological impact of the 8-inch bombardment extended throughout the Japanese garrison on Peleliu as word spread of Hill 100's destruction. Soldiers who had believed their bunkers were impregnable fortresses suddenly understood that American artillery could reach them anywhere, that no amount of concrete and coral could provide safety when 200-pound shells were falling from the sky. Corporal Kenji Nakamura, one of the few survivors from Hill 100's garrison, described the experience to other Japanese soldiers as being inside an earthquake, while buildings collapsed around you. The bunkers that had seemed so solid and permanent simply disintegrated under the sustained bombardment, their reinforced walls cracking and falling as underground explosions undermined their foundations. Nakamura reported that the worst part was not the explosions themselves, terrifying as those were, but the helpless realization that nothing they could do would stop the destruction. They could not return fire against distant artillery they could not see. They could not retreat because the tunnels were collapsing. They could only wait in their bunkers and hope the next shell would miss their position. Colonel Nakagawa received reports of the Hill 100 bombardment at his command post deep inside the Umabrogel mountain complex. The loss of his strongest defensive position, destroyed in less than an hour by artillery fire, forced immediate reassessment of his defensive strategy. The elaborate bunker system that was supposed to hold the Americans at bay for months had proven vulnerable to weapons he had not known the enemy possessed. Japanese intelligence had identified American howitzers during previous campaigns, but had classified them as medium artillery suitable for suppressing infantry and destroying light fortifications. No one had warned Nakagawa that the Americans could deploy 8-inch siege guns, weapons specifically designed for reducing the type of hardened positions his engineers had spent over a year constructing. The implications were catastrophic. If the Americans could destroy Hill 100's bunkers, they could destroy any fortification on Peleliu, given enough time and ammunition. Nakagawa's defensive plan had depended on bunkers holding specific terrain features while inflicting unsustainable casualties on attacking Marines. With those bunkers now vulnerable to systematic destruction by heavy artillery, the entire defensive concept was compromised. The tactical adjustments ordered by Nakagawa reflected his understanding that static bunker defense was no longer viable against American siege artillery. He directed remaining garrison units to abandon surface bunkers in favor of deeper cave positions, where overhead protection measured in tens of feet rather than the 3 to 5 feet typical of concrete structures. The caves offered natural protection that even 8-inch shells could not easily penetrate, though they lacked the carefully designed fields of fire and structural reinforcement that made bunkers such effective fighting positions. Japanese soldiers began the dangerous work of relocating ammunition and equipment from exposed bunkers to cave systems, a process that required movement across open ground under constant threat of American observation and artillery fire. Many soldiers died during these relocations, caught by Marine snipers or artillery as they transferred supplies between positions. Major Yamaguchi compiled detailed reports on the American bombardment, documenting shell impacts and analyzing the failure modes of his bunker designs. His engineering assessment concluded that the Type A bunkers could not withstand direct hits from 8-inch shells with delayed action fuses, as the combination of penetration depth and explosive force exceeded the structural capacity of reinforced concrete to absorb and dissipate. The underground detonations created shock waves that traveled through the coral substrate and attacked bunker walls from directions the design had not anticipated. Even bunkers that avoided direct hits suffered cracking and structural damage from near misses that detonated close enough to transmit destructive vibrations through the surrounding rock. Yamaguchi's recommendations for future defensive construction emphasized deeper positions with multiple layers of protection and wider spacing between individual bunkers to prevent sympathetic collapse when adjacent positions were destroyed. These lessons would inform Japanese defensive planning for subsequent battles at Iwo Jima and Okinawa, where bunker designs incorporated even greater overhead protection and more extensive tunnel networks. The success of the 8-inch howitzers at Peleliu reached Marine Corps headquarters within 48 hours, carried in after-action reports that described the systematic destruction of Japanese bunkers and the rapid advance that followed. Major General Roy Geiger, commanding the 3rd Amphibious Corps, immediately recognized the significance of the tactical breakthrough and ordered additional heavy artillery units deployed to support ongoing operations. The doctrine that had emphasized Marine organic firepower was modified to incorporate Army heavy artillery as an integral component of bunker reduction operations. Lieutenant Colonel Ayres submitted comprehensive analysis documenting the effectiveness of 8-inch fire against hardened targets, with detailed assessments of shell impacts and structural damage that provided valuable intelligence for future operations. His reports included recommendations for coordination procedures between Marine forward observers and Army artillery units, standardizing communications protocols, and target identification methods that maximize the effectiveness of heavy fire support. Sergeant Anderson's gun crew fired 237 rounds during the Peleliu campaign, systematically destroying bunker positions throughout the Umabrogol ridges. His technical expertise and consistent accuracy earned commendation from battery commanders who valued his ability to place shells precisely on target even under difficult conditions. Anderson kept detailed logs of each fire mission, recording target coordinates, rounds expended, and observed effects that provided valuable data for artillery specialists analyzing bunker reduction techniques. The experience gained at Peleliu informed training programs at Fort Sill and other artillery schools, where instructors used actual combat data to teach new gun crews the procedures for engaging hardened fortifications. Captain Mitchell's work as forward observer established procedures for identifying and prioritizing bunker targets based on their tactical significance and vulnerability to artillery fire. He developed classification systems that ranked bunkers by their construction type, overhead protection, and strategic importance, allowing efficient allocation of limited 8-inch ammunition supplies. Mitchell's coordination with infantry commanders ensured that artillery fire supported immediate tactical requirements rather than destroying targets of little operational value. His methods became standard doctrine for forward observers throughout the Pacific Theater, improving the integration of heavy artillery with Marine infantry operations. The strategic significance of the 8-inch howitzer success extended beyond Peleliu to influence American planning for the invasion of Japan's home islands. Intelligence assessments indicated that Japanese defenses on Kyushu and Honshu would incorporate extensive bunker systems similar to those encountered at Peleliu, but on vastly larger scales. The ability to reduce these fortifications through heavy artillery fire rather than costly infantry assaults became a critical component of invasion planning. Ordnance departments expanded production of 8-inch ammunition and began developing even larger shells for the 240mm howitzers that would provide the ultimate in bunker-destroying firepower. These preparations were rendered unnecessary by Japan's surrender in August 1945, but the tactical innovations developed at Peleliu continued to influence American artillery doctrine for decades. Japanese military historians writing after the war acknowledged that the introduction of American siege artillery at Peleliu represented a turning point in Pacific defensive strategy. Colonel Masanobu Tsuji, who survived the war and analyzed Japanese tactical failures, identified the vulnerability of static bunkers to heavy artillery as a fundamental flaw in defensive planning that should have been recognized earlier. His post-war writings criticized Japanese intelligence services for failing to identify American heavy artillery capabilities and for not anticipating the deployment of siege weapons to Pacific operations. Tsuji argued that more realistic assessment of American industrial capacity would have led to different defensive concepts, emphasizing mobile defense and withdrawal rather than static bunker warfare that played to American firepower advantages. Lieutenant Tanaka survived the war as a prisoner after being captured on October 12th, when organized Japanese resistance on Peleliu finally collapsed. His interviews with American intelligence officers provided detailed information about bunker construction techniques and the psychological impact of 8-inch bombardments on Japanese defenders. Tanaka described the evolution of Japanese thinking as the campaign progressed, from confidence in impregnable fortifications to desperate recognition that no defensive position could survive sustained American artillery fire. He reported that many Japanese soldiers lost faith in their leadership's tactical judgment after witnessing the systematic destruction of bunkers they had been assured would protect them. The psychological collapse preceded military defeat, with garrison troops abandoning defensive positions even before American infantry assaulted, because they understood that continued resistance only delayed inevitable destruction. The M1918 howitzers continued service throughout the remaining Pacific campaigns, participating in the invasions of Iwo Jima and Okinawa, where they again proved essential for reducing Japanese fortifications. At Iwo Jima, in February 1945, 8-inch artillery destroyed bunkers built into the volcanic rock of Mount Suribachi, allowing Marines to secure the island's southern heights. On Okinawa in April 1945, heavy howitzers reduced the Shuri Line fortifications that had held up American advance for weeks, demonstrating once again that no Japanese defensive position could withstand sustained fire from weapons specifically designed for bunker reduction. The total wartime production of 8-inch shells exceeded 1 million rounds, with approximately 40% expended in the Pacific Theater against hardened targets. Lieutenant Colonel Ayres returned to the United States in March 1945, carrying with him the Silver Star he had earned for tactical innovation at Peleliu. He accepted assignment to the Marine Corps schools at Quantico, where he taught combined arms operations and the integration of heavy artillery with infantry assault. His lectures emphasized the importance of matching weapons to targets, using Peleliu as a case study in how technological solutions could overcome apparently insurmountable tactical problems. Ayres never forgot the Marines who had died assaulting bunkers with inadequate weapons during the first week of the campaign, and he made sure future officers understood the importance of deploying proper firepower before committing infantry to assault operations. Sergeant Anderson remained in Army service after the war, eventually retiring as a master sergeant in 1962 after 24 years of artillery service. He worked as a technical consultant for defense contractors developing improved ammunition designs, applying combat experience to peacetime research programs. Anderson never spoke publicly about the specific effects of 8-inch shells on Japanese bunkers or the men inside them, but he maintained correspondence with former crew members who had shared the experience of turning theoretical firepower into practical results under combat conditions. Major Yamaguchi died during the final days of Peleliu fighting when American forces overran his command post on November 24th. Documents recovered from his position included detailed engineering drawings of bunker designs and analysis of American artillery effectiveness that provided valuable intelligence for subsequent operations. His professional assessment of the 8-inch howitzer threat, written just days before his death, concluded that Japanese defensive engineering had fundamentally miscalculated the capabilities of American siege artillery. Yamaguchi's final recommendation called for abandoning surface bunkers entirely in favor of deep cave systems, advice that Japanese commanders would follow during the final battles of the Pacific War. The legacy of Peleliu's bunker warfare extended into the Cold War period as American military planners studied the effectiveness of heavy artillery against hardened fortifications. The 8-inch howitzer remained in active service through the Korean War and Vietnam conflict, where it again proved valuable for destroying enemy bunkers and fortified positions. Improved versions incorporating longer barrels and more powerful propellants entered service in the 1950s, maintaining the basic design principles that had proven so effective against Japanese fortifications. Museum displays throughout the United States preserve examples of the 1918 howitzer and its ammunition, though few visitors understand the weapon's specific role in solving the tactical problems encountered at Peleliu. The National Museum of the Pacific War in Texas maintains a restored 8-inch howitzer in firing position, with interpretive materials explaining its use against Japanese bunkers. Educational programs describe the technical specifications and combat employment of the weapon, though they typically avoid graphic details about the effects of 200-pound shells detonating inside occupied bunkers. Manufacturing records preserved at the Rock Island Arsenal document the precision engineering required to produce shells capable of penetrating reinforced concrete before detonating. Quality control procedures mandated inspection of every shell to ensure proper fusing and structural integrity, reflecting the critical importance of reliable performance when infantry lives depended on artillery destroying specific targets. The industrial capacity that allowed American arsenals to produce millions of specialized shells while simultaneously manufacturing conventional ammunition represented advantages that Japanese industry could never match. The transformation of Peleliu from impregnable fortress to conquered territory required 73 days of sustained combat and cost over 10,000 American casualties. But the introduction of 8-inch howitzers on September 23rd fundamentally altered the tactical equation, proving that Japanese bunkers could not withstand American siege artillery regardless of how well they were constructed. The weapon that had been designed decades earlier for European fortress warfare found its ultimate purpose in Pacific jungles, where it broke the defensive system that was supposed to make American victory impossibly costly. In the end, it was not courage or tactical brilliance that decided Peleliu's outcome, but the systematic application of overwhelming firepower against targets that had been built to resist everything except the specific weapons the Americans brought to bear. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.